Hello, finance students. Today we are going to be talking about some basic financial economics. We're going to get really into the fundamentals of why people care about things like risk or uncertainty or and how our preferences for different kinds of goods and services actually feed into those kind of that kind of behavior by people. So it means we're starting fundamentally at the economic question, like what goods and services do people purchase, and build up to a theory of risk based on those fundamentals. So this is very much grounded. This is very much a microeconomics topic, but it will transition into a fundamental discussion and then increased understanding in risk. So to start that, I'm going to set the stage here. So let's say that I am at a restaurant and I have two options here. Let's say, okay, so first of all, I've got $5 in my pocket. So I've got $5. Oops, that is not how that works. $5. All right, so I have $5 in my pocket, and I have two choices. I can get an omelet. Oh, man, and I never... OMLETTE. That doesn't look quite right, but we could Google it. Oh, ELETTE. Did I OMEL? All right. Terrible. Struggling. OMELETTE. OMELETTE. All right, an omelet, or I can get pizza. So imagine, and both of those are $5. So they're menu items. They each cost $5, and right, they both cost $5, and I have to choose what I'm going to do. So what are some possible scenarios here? So obviously one scenario is I walk into the restaurant and buy an omelet. Another one is I walk in and buy pizza. Okay, so let's imagine that you observe me buying pizza. What do we know? So one thing you could say that we know is that my behavior, right, the way I'm acting in real life, is indicating that at least at this moment, I have we use the term revealed preference, right? I have a revealed preference for pizza over omelets. We can express that in this way. We can say, okay, let's say P is for pizza, and we're going to say pizza is preferred to omelets. It's kind of like a greater than, but sort of curvy. That's the symbol we use. And it just, right, it represents that this isn't a numerical quantity. There's not more pizza. It's just that pizza is preferred to omelet. So pizza is preferred to omelet, and that we know. So there is actually something else we know, though. And so this point gets a little subtle, but it is also true that pizza is preferred to $5, right? I chose to buy the pizza, and so that means I want pizza more than I want $5. What we don't know, right, is an omelet preferred to $5 or is $5 preferred to omelet? There's nothing in my behavior that would indicate to us which is which, right? So we know that pizza is better than an omelet. We know that pizza is preferred, right? Pizza is preferred to an omelet by me at that moment. A pizza is preferred to $5, and we don't know anything about omelets and $5. It turns out that this, in general, $5 is going to be preferred to omelets. I'm not a big fan of omelets, although there's a hero omelet at Fazy's in La Crosse, Wisconsin, that has, it's got the spice lamb and the tzatziki sauce and tons of yummy vegetables in it. That's good. So I'll do that. But unless it's a hero omelet from Fazy's, I'm probably not interested. So we have these general preferences, right? That we can express based on watching people's behavior. So this is all. None of this is really even all that controversial. Like, of course, if I'm in a situation where I'm choosing between buying a bunch of things or not buying, what I do is, that means something, right? That is a fact that is now true about the universe, that I went into the store and bought pizza, right? So, what we have a tendency now to do, or what we can define now, there's some the mathematical rules behind making this all make sense get to be, there's some detail you have to go through to make this a logically consistent system. But the basic idea is we can assign a number, and it's just an arbitrary number. So let's say we assign pizza a 7, and we assign omelet a 4, and we assign $5 a 5. $5 a 5. And that's just arbitrary, right? Pizza could be 1,000. It really doesn't matter. We're just making up some numbers. But the reason to use the numbers is to then allow us to translate what I want, right, my preferences for stuff in real life, to actual quantitative things. So we can say, oh, well, the number for pizza is 7, and the number for omelet is 4, and since 7 is more than 4, I want pizza, and that then accurately reflects how I behave in real life, right? So, these numbers are they just represent they're meant to be a convenient way to represent all of these pairwise preferences between all the possible things they could have picked. And right, what if this was 14, 8, and 10? Well, it's all the same, right? If you just make all the numbers bigger, you get to the same comparisons. And so it really doesn't, the numbers don't, there's nothing fundamental about the numbers other than that they encode this preference order. So something that also appears to be very true when you observe people in real life, and you can think about the logic here. So let's say I walk into this restaurant, and I am going to, right, buy, if I don't have any pizza, the total, points or whatever, we call this utility. The total utility I get from owning pizza is going to be 0, right? If I get one slice of pizza, we've already defined that to be 7. And again, we just picked that arbitrarily, but it does matter because when you compare it to other things, it needs to preserve the preference order. Now, what if I get another slice of pizza? Right? What if I get another slice of pizza? Well, it's entirely possible that the second slice of pizza isn't preferred to as many things as the first slice, right? That first slice of pizza maybe is super fantastic, and the second one is still pretty good, but, maybe, for example, if they had, a pair of really fantastic egg rolls, maybe those egg rolls for me are like a 6. And once I've already eaten a piece of pizza, I'm not as hungry, and so maybe those drop to like a 5.5, right? Because I'm not quite as hungry. They're not quite as good as they would have been, but they're still pretty delicious. But maybe pizza, since I've already had pizza, drops to a 5. And so if I've got $5 and I'm at this restaurant, my first move is definitely to buy pizza, but my second move isn't necessarily to buy a second slice of pizza. It might be to buy egg rolls, or, right, so let's imagine that my second move then would be to buy egg rolls, Now, this third slice of pizza, or the third food item I'm eating, maybe is not good at all, right? Maybe I'm full and I really don't care to eat more. So what's going to happen then is, right, maybe pizza's a 3, maybe egg rolls are 2, and omelets are a 1. I'm going to keep my $5, right? I have $5. It's worth 5. I'm just going to keep it, and right, and this just makes sense, right? If I walk into a restaurant with $1,000 in my checking account, I'm not going to leave with $1,000 of food. I'm going to buy food until I'm done buying food. And so what this means in practice is that if you observe human behavior, right, if you put people in experiments and make choices, this pattern consistently emerges over and over again. And that is that the more of something we get, the more utility it appears to give us, but the additional utility you get from each new thing decreases. So if I'm got 7 utility from the first one, the second one might give me something like 5. So then I'm up to 12, right? So I do like that second slice of pizza. I just don't like it as much as I'd like the first slice of pizza. And so you get, right, what ends up happening is you get like a curving shape where the utility, like those points values, goes like this. Now, in general, we assume that this never stops going up, right? If I have 100 slices of pizza and somebody wants to sell me a 101st slice for a nickel, I'm going to buy it, because I'll buy the pizza for a nickel, and maybe I'll freeze it, or maybe I'll give it to a friend, or I'll tear it up and feed it to birds, right? At 5 cents, I probably don't have any, like, I value it almost nothing, but I still value it more than 5 cents probably. So that curve goes up rather steeply at first, right, when we're getting our first tastes of pizza, and then declines over time. And this is a pattern that's approximately true for most things, right? So there's weird exceptions. For example, if I get a left shoe, the value of a left shoe is not very much, but the value of a left shoe plus a right shoe could be a lot, right? So that's kind of a goofy example, right? So there's exceptions where having more of something can be better in the short term, but that's gonna be unusual. That's not gonna be normal. So it's just as an approximation, right? So it is approximately true that you can just imagine things going less and less valuable as you have more and more of that. So that applies to pizza, right? That 100th slice of pizza is not that great. It applies to omelets. So what the important thing, though, that it applies to is if I just, this is pizza slices here. What's really important here is it also applies to money, right? So money in general also behaves this way. So, and you can kind of see how that would be, right? If I am homeless and someone offers me $20 for, some like food staples and hygiene products, I'm going to be pretty jazzed about that, right? If I have $1 million a year in annual income and someone offers me $10, I'm not gonna turn it down. But it's not. I'm not gonna get the same kind of awesome feeling from that, right? It's not worth as much to me. I have a bunch of money now. If somebody gives me, $500,000, well, that might, I'm going to be pretty excited about that, right? Maybe actually very excited, right? But that I might be as excited as somebody getting their first $30 that they've had in a long, long time, right? So money experiences this diminishing marginal utility as well, and it's this notion, this diminishing marginal utility of money, that really drives how we assume people. It drives why people's reaction to risk can be a rational response to their own preferences. And we can talk through that pretty simply just with some examples. So let's imagine here that I want a slice of pizza, right? And you can think about, right, so what's going to happen? I'm going to spend, right, so what's going to happen? I'm going to spend five. Oh, let me change this to be black here. I'm going to spend five. So I'm going to spend $5, and in a way, that's also 5 utility, right? Because that happens to be 5 utility points. So I'm going to spend 5. Let's just say spend $5, right? Spend $5. Ooh, put a D on there. Spend $5. And I will get to buy 1 pizza slice. Okay. So where we're so in the so then the question, right? The question that will kick off the next video is to say, what if I gamble the pizza? That seems a little weird. We can say, well, what if I flip a coin and go to 2 slices or 0 slices? Obviously, right, I get the same amount of pizza on average, right? If I have a 50% chance for 2 slices, the amount of pizza has not changed, right? So if the amount of pizza has not changed, it seems like I could do it or not do it, and it doesn't matter. But it turns out it actually does matter quite a lot, and in general, we would never, ever gamble the pizza. And that might be your tuition as well. You might think, oh, wow, yeah, I probably wouldn't do that if I had that chance. And so understanding why is important. So that's what we'll get into next time.